Find the cube root of 1,728 using prime factorization and or estimation. Now we saw the estimation strategy before. It was a very guess and check scenario. So this time we're going to rely on our good old prime factorization to help us out. But I want to just remind ourselves of the difference between a square root and a cube root. So let's start with 2, for example. And if I said 2 multiplied by 2, I know that I get the number 4. I also know that 2 times 2 is the same thing as 2 squared. And I also know that the inverse of that, we call it the opposite, is the square root. And I say the square root of 4 is 2. So 2 times 2 is 4. Therefore, when I take the square root of it, I'm looking for a number multiplied by itself twice to get to the square root. The cube root, on the other hand, is a little bit different. If I take 2 multiplied by 2 multiplied by 2, I actually get 8. And in this particular case, we know we can write that as 2 cubed. But I also know it has to have an inverse here. Its inverse is not a square root because I'm looking for 3 numbers multiplied by themselves to give me my answer rather than 2 numbers multiplied by themselves to give me my answer. So I'm looking for now the cube root of 8. And the cube root of 8 happens to equal to 2. So although I have the same answer in both cases, in this particular instance, I had a square root, and in this particular instance, I had a cube root. For a cube root, we are looking for a number multiplied by itself 3 times instead of only twice. We're going to go with our old reliable of prime factorization, because we haven't quite investigated the cube root list as much as we've investigated the square root list. Now I see 1,728 is an even number, so I'm going to take a wild guess. Any even number, I don't know, 18, 28, 36. I'm going with 36 just because I feel like it's my friend right now. I don't know why. So 36 actually worked out nicely as 36 multiplied by 48. That'll get me to 1,728. Neither of these are primes. Both of them are even. So we can go with Old Faithful and divide by 2, divide by 2, divide by 2. Or I could recognize that 36 is the same thing as 6 times 6 because it was on our perfect squares list. Neither of these are primes, so I'm going to break them down into 2 times 3 and 3 times 2, or whatever order you would like. But luckily, they're all primes anyway. And 48, I'm going to take 48 and I'm going to divide it by 8. And I know 6 times 8 is 48. Well, 6 we know breaks down into 2 times 3. There's a lot of 2's and a lot of 3's. And 8 this time breaks down into a 2 and a 4. 4's not quite there yet, so we have to go one step further and break it down into 2 times 2. So we can rewrite 1,728 as 1, 2, 3, 4, 5, 6 2's. 1, 2, 3, 4, 5, 6, and 1, 2, 3 3's. Now, again, in our last example, we kind of tried to loop all the 2's together, and group all the 3's together, but that's not making anything even for us. And what we're looking for is the same number multiplied by itself 3 times. So I'm going to try and break this apart so that I can actually have 3 groups of numbers that all look the same. So I'm going to start with the 2's. I have a 2 and a 2 and a 2. So why don't I get rid of this one, and this one? Looks like I have a second set of 2's. So I'll put all those 2's partnered up evenly into those 3 groups. And lovely for us, we also have a 3 that can evenly be grouped into the 3 groups that we've got going on. Now, 2 times 2 is 4, and 4 times 3 is 12. So I can actually say 12 multiplied by 12 multiplied by 12 should equal to 1,728. Double check that on your calculator. Actually put 12 multiplied by 12 multiplied by 12, hit equals. I should get 1,728. So we can rewrite that as 12 cubed. is 1,728, but more importantly, the question actually asked for the cube root of 1,728, and now we know the answer is 12.